So guys, without further ado, let's begin. Um, we're here because for a really long time, I've been doing these trainings for corporates. And I have been immersed in the Linux ecosystem and specifically the Linux operating system for a really long time. It's almost embarrassing. It's well over 20 years. Okay, so um, just to give you a brief, I joined the industry back in 91, a long time back. And I worked initially at a startup where we built an antivirus solution based on a hardware card, a PCI card, which was quite unusual at the time. So I, really learned to hack at the level of C and assembly language. Yes, assembly. Although in those days we worked on DOS and on the old x86. But it was a fantastic foundation because it taught me how the machine really works. Later, I worked in a few companies, and many years back, I last worked at Digital Equipment, DEC. You know, um, Interestingly, Unix was literally invented on a DEC machine. Uh, that was long before I worked there. That was like 1960s, late 60s, early 70s. Anyway, um, while at DEC, I first started doing training for corporates. And after a while, I left to do my own thing. And, learning about Unix taught me that it's an incredible operating system, especially for people on the system side, developers, what we today call DevOps, testing, and, the rest of it. So I had this feeling that I must somehow get back to working on Unix. And like, Magic Thunderbolt, I kind of discovered that there is this free version of Unix called Linux. And this was back in about 96, 97. And it was incredible. I installed it on my PC. And, I literally haven't looked back since those days. I've always been on Linux. Okay. Along the years, I worked at a few companies. Quite often in the role of contract developer or a freelancer, however you want to think of it. But I gained valuable experience working on Linux projects. The whole notion of open source was very appealing. So I started learning more and more. I literally self-taught myself. In fact, at one point I had this goal. Because it's open source, I want to understand deeply how the operating system works, in effect, the kernel. So, that's the beauty of open source. It is open to any and all of us. And it is just up to us to put in the effort. Now, of course, the effort is huge. And I was lucky enough to be able to devote time to this. So I did make progress. Um, After some years, other companies started calling me to do corporate trainings. And from around 2000 onwards, I did a lot of it for so many years. I still do it. I also contribute to projects, both open source and closed source, commercial, when I have the bandwidth. With open source, it's a bit easier because you can take your time in effect. Okay. So anyway, guys, another interesting thing happened in 2018. A UK-based publisher approached me and they said, would you be interested in writing a book on, guess which topic? Linux system programming, the same course that we are just about to launch. So I was happy to say yes. And I got working and it took about 9 or 10 months and the book got published. So it was a huge amount of work. I won't pretend it wasn't, but I actually enjoyed it. I think it's part of my calling to be able to teach people. There are a lot of people who are much smarter than I am, who know much more than I do about Linux. But luckily, I have found a way to communicate what I've learned. So I think that helps, as with in any field. So I did write this book. And sorry, give me a second, guys. This is my Amazon author page, guys. As you can see, I've been lucky enough to be able to work on these books and get them published. This was the very first book, Hands-on System Programming with Linux. In fact, it is the subject matter of our upcoming course. So that was the first book I wrote and got published. And after that, I wrote a book on kernel programming. And the one you see here is the second edition, because this book did really well in the market, I'm glad to say. So is this book, the second edition. Um, Along with this book, we released a companion volume on the basics of writing device drivers. which is this book. Okay. Guys, I have a piece of good news for you all. Everyone loves a freebie, and this book is free. The Linux Kernel Programming Part 2. It teaches you how to write character drivers and a lot of important related topics. So guys, you can either download the Kindle version or you can go to the GitHub page. All my books have a dedicated GitHub page where all the code is. And in the case of this book, even the PDF is there. So, please download it, have a look. After that, I wrote a book on kernel debugging. So, it's a total of 5 books. And have I stopped writing? Well, not really. In fact, just this year, I've signed the contract to work on more details about drivers. So it's like an upgrade to this book. And that is something I'm just starting out on. So, I keep busy doing all of. I was just saying, as we go along the course, I will be sharing my GitHub repos. And of course, they're all open source. So, there's even now you can access them. So I'm happy to share that every book has a GitHub repo. The code is free and open source. And I have many other repositories, some of which we will be using depending on the course. Okay, guys, as a matter of fact, this is the repository for the system programming course. So we will be using this one pretty much in depth. You are free to have a look. You are free to clone it and use it. Okay, but of course, the real gains come with understanding the materials and then going into the code level. In fact, we do them side by side all the time. Okay, the course is very hands-on, practical oriented, and I always try and make it relevant to what industry needs. So I put a lot of effort into keeping myself up to date with what industry needs. A lot of my workday is spent in doing that and learning new technologies and updating it in my training materials, and if I am working on a book. So of course, that's just part and parcel of how it's done. Guys, if any of you wonder, is Linux still relevant? It's even more relevant today than ever before. Why? You can see these bullet points over here, but even more importantly, these days everybody talks about AI, and with good reason. There is a lot of hype, but there is also a lot going for the technology, and I'm sure in the coming years it will gain. So guys, let's ask ourselves this. Where are we placing ourselves in the domain? Are we directly working with AI? Do we work on AI apps? Are we part of that ecosystem? So see, ultimately, we all will be. And I like to think of people like myself, probably many of you. And I see that many of you have already signed up for the course. Thank you. What was I saying? We start to realize that the whole infrastructure that AI is built upon is the Linux operating system. This is not some hyped up thing. See, guys, all modern software is deployed via cloud because that's the only way to scale it, to hyperscale it. And all the hyperscalers do exactly that, right? We know, right? The big 4 companies in tech. This is exactly what they do. They use either their own cloud or another cloud to scale their services on a global basis. And this is how AI is being deployed as well. And what runs the cloud? Linux, in a nutshell. It is Linux. So see, guys, it's not just the cloud. The tiny embedded devices to supercomputers, they're all running Linux. Your Android phone runs a Linux kernel at heart, as many of you know. I can see Kunal there. Hi, Kunal. Kunal is into this domain. He works on Android firmware, and he can tell you these things. So, I would say the scope is only increasing because we know AI is poised to become a big thing. So why not get ourselves into the position of being people that AI depends upon? Because AI infrastructure is Linux, guys. What else is it? Okay, you might say, what about Microsoft Cloud? Isn't it Azure? Yes. Do you know that Microsoft says more than 50% of their VMs are Linux? See, they have an amazing cloud platform. but customers are choosing Linux more and more. It's just become brilliant at whatever it's done. Now, why is Linux so pervasive and popular? It's not because it's free. Linux is not free. It is free in the sense it's open source. But see, guys, if you want to run a business on Linux, it costs money to do so. I mean, obviously, right? If you hire a programmer or two and a DevOps guy and so, doesn't it cost money? So a lot of the business model is where companies are saying, we will take care of the whole infrastructure, IaaS and PaaS, and you just run your core business. Don't worry about the techie details about running Linux. So there's an opportunity there, and big tech knows it very well. Okay, this is besides consumer products. It's huge. Okay, so folks, this slide kind of sums that up. Okay. Um, let's get practical in this session, and I don't want to hijack your Sunday. So why don't we do something interesting? See, I'm not trying to show off, but this is the tip of the iceberg. There are 4 demos listed here. I can show them to you, but it will take too long to show you all of them. The stuff I show you here, I will use in a course, but it depends on which course. So guys, since our system programming course is around the corner, the first demo is very relevant to us. So is the second, and to some extent, demo 4. Building a basic embedded Linux is obviously something I do in the embedded Linux training. But for the fun of it, I'll just run one of my projects. You will see a small Linux system booting up on Qemu, the quick emulator. Okay. In fact, maybe that's a nice way to begin. Okay. Why don't I just quickly do that? I have an open source project called Seals. Guys, I won't explain anything right now. I'll just run this. You can see my screen, right? See, folks, this is the Qemu emulator. This is the command that my shell script has generated. And when I press enter, this command will run. And it's emulated an embedded platform. Particularly, it's called the Versatile Express 815 because it uses a Cortex A15 CPU, which is an ARM type of CPU, ARM 32-bit. And here's the kernel. So my project has built a Linux kernel. My project has built a root file system. And these are kernel command line parameters being passed to the project. And this is the so-called device tree blob. I will explain these things in detail when we do an embedded Linux course. But now's not the time. Now we just run it. So isn't this interesting, guys? You have literally seen a Linux system boot up. All these messages are kernel messages. We call them kernel print case. So you are literally seeing Linux coming up. Okay. I built this kernel. It's a 6.1 kernel, which is actually relatively recent. And nothing is hidden. I built it on March 12th last. Okay. And right at the bottom, if I press enter, I get a console. So see, guys, we are in a Linux system. It's a small, tiny embedded Linux, which I have built from scratch. And I will teach you how to build this when we do the embedded Linux course. Okay, but now's not the time. So guys, pardon me, but I will just power it off. Okay, so this is just to show you that with Linux, you can do anything, guys. It's just about some mastery, which comes with knowledge and practice. Okay, putting in your effort. See, I won't kid you also. You won't become an expert in 1 week. I'm not promising that. Nobody can promise that. But if you learn the theory, the concepts, the code, the practice, and you put in the hard work, you will. Nothing prevents you from becoming an expert. Okay. Let's move to another demo. So see, guys, I showed you my GitHub thing, right? And under L1 system programming training, where is the chat window? Yeah, here it is. So folks, you got that, right? In chat, I've sent you the GitHub URL. Okay. Yeah, that's true. Yeah. Okay. Thanks, guys. Here we are in the L1 system programming GitHub repo, and there's a hello world folder, and here's hello world.c. Now, guys, I don't need to explain to you all how to write hello world. When you learn C, the first day, probably the first hour, you wrote this code, and it worked, right? But I always tell people, be empirical. Empirical means don't believe anyone, don't believe the book, the tutorial, the trainer. Try it for yourself. Always try it out yourself. So over here, we have our amazing, complicated hello world program. So I'm being sarcastic. But you know what? When I do the system programming course in the first session, I will show you how complex this really gets. Okay, because we look under the hood. So I'm going to give you a taste of that right now. So guys, we all know how to write hello world. And over here, I have a make file. Now, don't worry about the details, but I think, if you just look at these two lines, it's sufficient, because you can clearly see that we are building hello world using the compiler, correct? Let's just do that. Okay. In fact, why don't I do it manually so that there is no confusion? Okay. Guys, what is minus wall? Warnings all. It's very important we do things like this because it is our job to detect and fix all warnings. It built without warnings. And here is the binary executable. Now, the proof of the pudding is in the eating. Let's run it. It works, right? So clearly, it worked. Now, guys, I'll show you another crazy thing about Unix and Linux. Just watch this. I'm going to rename Hello World to Hello World. Let's call it myhelloworld.c. Now, see, guys, it looks like a C program, correct? So then you would say it can't run, right? It can. Did you see that? So what does this prove? This proves that the OS doesn't care about the file name. People care about the file name. Applications care about it, but the OS doesn't. So the way to determine the type of a file is to use the file command and not to trust your eyes. Be empirical. So if I do, oh, sorry, I did hello world.c. So it's correct. See? But now I will do my hello world.c. And now see what it says. It's an ELF executable, which executes on the x86 64-bit. Isn't that interesting? Executable linker format. Okay. So folks, that is how we have to think. Now, of course, for God's sakes, don't name executables as .c, although we have learned that we can. Now let's start digging deeper. So see, guys, let's do one, silly thing. Here's hello world. Okay. Now, the only real line of code is the printf. Now, we have been taught when we learned C that printf is what makes hello world come on the screen or the monitor. Now, guys, one technical thing. We don't call this the screen or the monitor. We call it the console device or the TTY device, the teletype terminal. It's an old Unix word. It's where input and output goes. Okay. I mean, haven't you seen me type? So I'm able to give input and it's able to echo some output. It's the teletype terminal or the console. So technically speaking, sorry guys, there are too many windows open over here. Technically speaking, it looks like the printf is writing to the console or the TTY device. But I'm here to tell you that that is not true. If you were taught that printf writes here, that's a lie. So then it brings up the question, what does the printf do if not write hello world to the TTY device? So guys, the answer to that is more complex. We start understanding how the system works. So first and foremost, I ask you all a question. Printf is a function, right? And isn't this the parameter to the function? Yes, of course it is. It's a string, fine. But where's the code of printf? We haven't written the code of printf here, but then it can't just work by magic, right? So how is it working? So folks, what is the answer to that? Can anyone say? Where is the printf? You could type into chat if you wish. Or Not sure if it's possible to unmute. Perfect. Sridhar, you are bang on target. It's in a library, standard library. Ali is on target as well. So folks, totally right. It must be somewhere, right? It's in a library called the standard C library. Now, in traditional Unix, it's called libc, but on Linux, it's called glibc. Why? G for GNU project, which Richard M. Stallman started. Now, folks, that's another story by itself. Let's not get into that now. There is a library called glibc. It's a big library. It's got 2,000 odd functions, APIs within them. Printf is one of them. Now, if it's a library, don't we need to link into the library? It's automatic. Every single binary executable on a Linux box auto links into glibc. Now, you might say, it's easy to say, can you prove it to me? I can. There's a utility called LDD. LDD shows us our library dependencies, among other things. So see here, guys, you see this line. That proves to us that we are linking into libc. This is the shared object on my box. It will look similar on your Linux system. Okay, so there's the proof. Now, guys, I will explain these things when we do the course. Okay, for now, you can ignore these things. This is the loader. It sets up the C runtime environment. Okay, now let's continue with what we are talking about. Fine, printf is a library routine. The library is built in. It's automatically, dynamically linked to. Good. So what next? The code of printf runs. What is a library? A library is an archive. It consists of code and data of functions in the library. Okay, so they run and do something for us. Okay, great. But I said that printf doesn't write to the TTY. Then how does it work? So guys, now I'll give you a bit of background. When a process is born, it inherits 3 open files: standard in, standard out, standard error. I will explain what they are there for. The file descriptor is an index into an array in the kernel. Don't worry about it. Okay, but just understand that these 3 open files are always present. Now, what do they mean? Standard input is how you send input to the process. So guys, by default, the standard in device is the keyboard. Doesn't that make sense? Okay, this is always the case. So similarly, what is the case for standard out? The default standard out device is the, well, colloquially we say screen, right? But I just told you, the more technically correct way to say it is the console device or the TTY device. Okay, so this is where output goes. And guess what? Standard error is where errors go, and it is identical to standard out. It is by default the screen or the console or the TTY device. Okay. Now, guys, you might wonder, what the hell is he talking about? We are trying to learn how Hello World works, and why are you explaining all this? So just bear with me. See, folks, once we understand this, now see what I'll say. When you call printf, it performs its processing. Now, you know what its processing is? It's the printf format string. See, guys, printf, the intelligence of printf is being able to figure out the format string. So, you know, things like \n, %s, %1.5f, that is what printf can do. And that is what it's very good at, but nothing else. After printf figures out the format string, it puts the data in a buffer. Okay. And that buffer, it writes to the standard out device. So, guys, here is standard out. Printf writes to standard out. Now, to write, standard out is a file. Why? Because of this. If it's not a process, it's a file. So guys, see, think about it. It has to write to a file. Which file? Standard out. So how do we write to a file? Don't we need an API? Yes, we need an API. Guys, don't you know the API to write to a file? There are many. But at the bottom, it's called write. You see, this is what printf calls. This is how it really works. Printf calls write. That is how it works, guys. And write is the API, oops, that actually performs the write to the destination file. This is how it really works. Okay, this is just annoying. Fine, folks. Okay, Ali has a question. Can we directly call this API rather than calling printf or gprintf? Yes, the answer is yes, you can, because it is available to us. Now, how is it available? It's within libc. But now we come to one fundamental point. The code of write in glibc is not the actual code. Then where is the actual code? It's in the Linux kernel. See, folks, we've come to a really, really key point. There is a bunch of functions, APIs on Unix and Linux called system calls. They are special. Why are they special? Because their code is within the kernel. And that is very different from a library. So you might ask me, but didn't you say it's in glibc? Yes, it's only a dummy placeholder, a stub. glibc holds the syscall stub. It's the code that invokes the actual code within the OS or the kernel. This is how it really works. So see, guys, even in this short time, we've learned a lot. I don't have time to draw a nice picture, but here is a basic picture. I'll make it much better when we do the course. Okay. What we've learned is that processes run over here. This we call user space or user mode. You see, we call it user space. And this we call the kernel space. Okay. And we've learned that you can call printf and printf will become write. But guess what? The real code of write is over here. It's not in user space, it's in the kernel. Why? It's a system call and it comes here. Now to come here is something special has to happen. Okay. We have to cross the boundary between user and kernel space. That is not allowed by default. It is a privileged activity. But that is the whole point of a system call. System calls are special because they are the gateway. They allow a process to switch from unprivileged user mode to privileged kernel mode. See, guys, that is the key statement. Okay. And that is what happens under the hood. And now the code of write runs, and this code has the intelligence to be able to write hello world over here. All this happens in a fraction of a second because computers are fast. But this is how it happens. Now, you know what? I haven't explained anything here because it's far too early. When you learn about kernel internals and drivers, then we start going into these details. Okay. See, guys, Linux is a vast arena and you have to go step by step, but you can. That is the amazing thing. Nothing is hidden from us. Okay. Now, folks, see what I'll do now, something practical. We have hello world. I want to see how it works from the command line. So guys, we have tools. In Linux now, we have not dozens, but hundreds of tools. And the more that you learn, the better you become. So we have a tool called ltrace to trace library APIs. So watch the fun. ltrace shows me that I called hello world, and this is the output, and the return value is 13. Can anyone guess? It's the number of bytes written. Okay. Okay. Kunal has a good question. Sorry to divert, guys. Is the process running in kernel, or is kernel executing privileged work on behalf of the process? That's a great question, Kunal. The answer is the former. The whole model, what we call monolithic kernel design, is that when a process issues a system call, it switches to kernel mode and runs the kernel code. That is another really key point that I emphasize in the first module of our system programming course. Guys, you all will learn these things in depth when we run the course. Okay, but that is the answer in a nutshell. Now, I want to show you something else interesting here. Didn't our code call printf? Yes. But why is it saying put s? Guys, puts is a function, no? You all know that, right? Put string. I looked up the man page. Okay. See, folks, this is compiler optimization. Puts is faster than the printf. So the compiler has the intelligence to say, let's run puts. The end result is the same. Amazing. Okay. Let's leave it at that for now. So ltrace has been able to show us this. Guys, let's take a better example. We all know if you run ls, you will see the files and folders in the current directory. But how does ls work? You want to learn? Why don't you ltrace it? Every single library API issued by ltrace is seen over here. Amazing, right? You can investigate what is going on. This is a debugging technique and a learning technique. It's incredible. Okay, you can do it with anything. You don't need any special compiler flags. Now, think about it. We were at the library layer looking into, guys, this is not a good diagram, but imagine that this is the library. So printf was in there. Okay, we saw it, but we know that printf called write, correct? So now I want to see the system call. How do I prove that that happened? strace. Guys, learn how to use ltrace and strace, and it will solve a lot of your problems. So let's strace hello world. Do you understand? We are now tracing the system calls that this process executes. Now it's surprising. The output is surprising. Sorry, guys. How come there are so many system calls? Isn't it just one system call? The write. That's what we said, right? Then what the heck is all this? See, folks, I won't explain the details now because we don't have time. This is all the C runtime setup performed by the loader so that our work gets done. Just trust me for now on that. But guess what? Ultimately, the write system call is issued. We can literally see it. So now we know how hello world works, exactly like this. But you might ask me, okay, I agree with you that printf calls write and write is a syscall. You have proved that. But I want to see what write does in the OS. You are not showing me because see, guys, we just see the write. It's a black box. The OS is a black box. Can I see inside the OS what the write system call does? Yes, we can. Guys, I always tell people on Linux now, pretty much nothing is hidden from you. If you put in the work, the effort, you can see anything and everything. So you want to see what's going on in the kernel? We have a subsystem in the kernel, which is deeply built into the kernel. It's called Ftrace. With Ftrace, you can see what happens inside the kernel. The black box becomes a white box. Okay, we use this for understanding, for learning, for debugging, obviously for debugging at a very deep level. Okay, now I can't cover Ftrace in detail here. We do it when we do the kernel internals course, kernel programming course, the L2 course, fine. But guys, I can demo it to you. Using raw Ftrace, which means Ftrace at the level of the kernel is quite difficult. So the original author of Ftrace, his name is Stephen Rosted. I think he now works with Intel or Google, I'm not sure. He used to work with Novell for many years. He wrote a wrapper over strace called trace-cmd. It's a utility in userspace. Now, you can learn how to use trace-cmd, and you should. And when I do a kernel programming course or a driver course, I definitely show people these things. Now, guys, me being a little lazy, I wrote a wrapper over the wrapper called trace-cmd. It's a wrapper over trace-cmd. You understand? Let me just show you. So to make things easy for everyone, I wrote a script which will call my trace-cmd. Okay, guys, don't worry about the details. Okay, over here it calls my utility. I'll just run it here. Okay, just look. Okay, you need root access for this. Now it's running trace-cmd. Guys, you see this command over here? This is where I'm running trace-cmd, and you can see our hello world has come to standard out. So we know it's worked. And I have captured the ftrace output and I've put it in a file. One line of code has become 3.6 MB of output. See, guys, it's quite amazing. This output, these are functions in the kernel, guys. This is all kernel code. This is the kernel code that ran when I ran Hello World. See, folks, this is the system call to execute a process. We learn it when we do the system programming course. It's the exec VE. You are literally seeing it execute in the kernel. Here is the opening of a file. And guys, it's over 31,000 lines for Hello World. Now, that's too much to read, no? There's too much to read here, and we have to learn how to filter this output. There are ways. There are good ways to do all that. But now let me go to the heart of it. It called write, no? Where is the write? I'll give you a very useful tip. Any system call foo in user space, in the kernel, this is user space, this is kernel space. In the kernel, it very often, not always, but very often, it becomes sysfoo. And sysfoo often, but not always, becomes dofoo. This is how Linux is designed. Now, not all the time, but very often. Okay, so guys, see, if I want to see a system call, shall we say, read, then I search for sys_read. Okay, oh, sorry, I didn't type it correctly. Here, I found it. Over here, it's called x64 sysread. So this is a read system call. It's happened about 52% of the way down. But I'm not interested in read. Why? Because I'm interested in the write. So guys, just see how easy it is. Search for sys_write. And at 76% of the way down, we find the write that the printf called. This is kernel code. And guess what? It has the intelligence to figure out where to write. It wrote to the TTY. So guys, this is my demo to you. Deep in the OS, this is how it works. And now the details of TTY write follow. This is how Hello World works. So if you think, if you think it's simple, it's not. At a deep level, it's complex, and we can see it. Back to this. I just want to say, when we do the system programming course from Thursday onwards, we will cover a huge amount of stuff. So see, I won't kid you. It will need your attention and focus. It is quite intense. It is quite demanding. But that is when we learn a lot, when we push our boundaries. So put in the effort. I will be giving you assignments, exercises, so that until you do things hands-on, you don't fully understand it. Theory is not enough. You need to work on these things. Okay, so guys, there's a huge amount that we cover, and it is demanding. But I will do my best to answer your doubts. You can always email me even later and ask me questions. I will give you time. Okay, we cover a lot of very relevant content that is relevant to industry. And I always try and teach people, where problems occur, where it's not clear what is going on. How do you figure things out? How do you write code using best practices? Because see, we don't want to write fragile code that will break tomorrow or in 1 week or in 1 year from now. We want to write solid, robust code, because then you will be in demand. People will start recognizing, hey, that when this guy works on the project, we are solid. That's the intent. Okay, we want to get to that place. Fine. So I will cover all this in detail, but you have to put in a lot of work. I'm not going to sugarcoat that. Okay. There will be quizzes that you do. There will be assignments, and of course, the full day session. Okay. And guys, because of the amount of depth, we won't always get time. Like I can't tell you, spend 2 hours doing this assignment. It doesn't work. So I will give you time where possible, but it will spill over, and then you need to work on your own. Important thing, prerequisites. I expect you know the basics at least of C. I'm sure you do, but in case you've not, please brush up. Okay. I expect you know how to use Linux on the command line. Again, you don't have to be a guru, at least the basics. Just, using commands like ls, ps, find, grep. That is important. Fine. Now, very important. You need Linux, no? You must install a VM. See, guys, this is a Google Doc. It will give you details on how to set up a VM. Okay. Now, I found one convenient thing here. There's a really nice company called OS Boxes. they have pre-built images. Just go to osboxes.org and you will find all Linuxes. This is the link to Ubuntu 22.04. It leads to this link. Okay, this one. Download this file, extract this file, and follow these instructions to install it on VirtualBox. Guys, I think I've given enough detail so that you can follow this and do it. And here's the username password to log in. Okay, username password. Fine. There is another way to run Linux. With Windows 10 and 11, you can use Windows subsystem for Linux. It's essentially an Ubuntu VM running on Windows hypervisor. Okay. This is another way to do it, and here are the guides. So, I'm okay with it if you use this as well. Although I don't use this way, I run on native Linux. My system is Linux, but I also run VMs. So see, folks, I did this morning. I set up OS boxes. Okay, so here I am running the OS boxes Ubuntu 22.04 LTS. And if we all get this installed, we will have a uniform environment. Here is my Oracle VirtualBox application on Linux. And you can see that the OS boxes VM is running. Okay, and this guide will teach you how to install it. And at the bottom of this guide, you should copy paste these commands after you've installed Linux to install necessary packages. So guys, I've given everything in detail. You will get a certificate when you finish, signed by myself, a PDF.